Okay. Good evening and welcome to our third public lecture in our spring 2021 webinar series. My name is Amy Merkel and I'm a research scientist at LASP and our current lead for our Office of Communications and Outreach. It's my great pleasure to introduce you to our panel of speakers this evening. Pete Withnell, Dr. Mike Chaffin, Mohsen Al-Awadi, and Heather Reed. All four speakers work on the Emirates Mars Mission, EMM, which is the topic of tonight's webinar. I will give you a little bio of each speaker now, and then they will each take a turn speaking about the mission. We'll have a full panel of a question and answer at the end. Feel free to ask questions in the Q&A window during the talks, and they will do their best to answer as many questions as we have time for. So I'm going to switch it to gallery view so that you can all see everybody as I introduce them. So first is Pete Withnell. He could give a little wave. Pete has 25 years of experience in the space industry, developing space instrumentation and managing teams on numerous LASP programs, including SNOWY, SOURCE, AIM, and TSIS, and many more. Pete has worked on EMM since its conception and is currently the EMM program manager, leading the team to fulfill the international collaboration goals of the project. He's responsible for the design, development, testing, and operations support of the spacecraft and the 3 science instruments. Dr. Mike Chaffin, can give a little wave, is a research scientist at LASP with a focus on understanding the evolution of planetary atmospheres. Mike earned his PhD from the University of Colorado in Boulder's Astrophysical and Planetary Sciences Department in 2005 while working on the MAVEN mission. On EMM, Mike is part of the science team working with the EMU's instrument, which you'll hear more about. Mohsen Al-Awadi, can give a wave. It works for the United Arab Emirates, UAE's Mohammed bin Rashid Space Center, MBRSC in Dubai. Thank you, Mohsen, for joining us, as I hear it's 6 a.m. in Dubai right now, so early morning for you. Mohsen joined MBRSC in 2014 as an aerial systems engineer, and in 2015, he started working on EMM and currently works as a mission systems engineer on the mission. Heather Reed, give a little wave, has 25 years experience in the space industry as well. Heather managed LASP Mechanical Engineering Department for many years and has worked on many of the missions that have come out of LASP, including SNOWY, Time-C, SOURCE, AIM, GOES, and MAVEN. Heather has worked on the EMM since its conception as well, and is currently the instrument payload manager for the 3 science instruments. Thank you all for joining us this evening. Very excited to hear you talk about EMM. And now I'm going to turn the presentation over to our first speaker, Pete Withnell.
Thank you, Amy. Good evening, everybody. First of all, can you see my screen? Yes? Thank you. I have a lot of ground to cover here and not very much time to do it. So first of all, I'm going to be talking very quickly. I'm also going to try and accomplish that by not just addressing the title of the talk, but rather focusing on a specific word, and that word is unique. I'm often asked, what makes EMM unique? That's a great question. We often refer to EMM as being very different from other programs. So I'm going to try and answer that question from different perspectives. But before I do that, I want to just talk about what EMM is to try and get everybody a little bit more onto the same page. So this rather complex view is a rather good description, at least at a high level, of what EMM is. And at the top, you can see that EMM, or the Emirates Mars Mission, is a program with a goal to place a spacecraft with 3 scientific instruments in orbit around Mars to perform compelling science observations of the Mars atmosphere. Now, Mike Chaffin will describe this in greater detail than I could in a couple presentations. So I'm not going to say anything more from that perspective, but I do want to point out that the mission originates out of the UAE, and for which this program has the overarching goal to provide a stimulus to their science and engineering sectors of their economy. The program, in fact, reaches out to the youth of the UAE in particular and offers a new source of hope to them and to their region. Now, Mohsen's going to speak more of this from his first-person perspective, but for now, I just want you to know that knowledge transfer through direct hands-on experience was and continues to be a major driver for how this program is implemented. And more on that aspect in a few slides. But in this view, you can see a few of the major aspects of the program. You have already said the lead of the organization comes from within the UAE, and it is the Mohammed bin Rashid Space Center. And from here on, we will likely refer to that as MBRSC. Now, 7 years ago, in order to accomplish this enormous task, they reached out to LASP at CU, as well as the University of California at Berkeley. Now, later, Arizona State University joined this partnership as the fourth institute, but there you have the four main partners. Now, there isn't time to go over the challenges and the intrigue the team experienced over the last 6 years in the development cycle, but I do want to point out a number of aspects that truly make this mission unique. So just by the numbers, at the peak of the program activity, over 140 LASP employees were directly supporting EMM. That's a big number compared to other LASP programs. If we then branch out to the other partners that I just mentioned, if we include all four of the main partners, organizations of the collaboration, we can get to 500 people. If we then further add subcontractors, mostly coming out of LASP, this number can easily exceed 1,000. So just in terms of sheer people, this program was large and it was complex. It also included a significant number of subcontractors, 27 of which had subcontracts of the value of $1 million and up. The total supply chain, if you look at all the parts and pieces that were needed to fulfill the needs of the spacecraft and the three instruments and the operations, that's a number that's easily over 100 vendors. And those were really spread across 8 different countries that are listed here. This really makes EMM the largest program that LASP has undertaken from a number of personnel perspective, an organizational perspective, and most likely from an international involvement perspective. So it was a very big deal. But apart from the sheer size, I'm going to continue on a little bit of a LASP-centric discussion here and just look at the LASP campus here. I said 140 people from LASP. Well, those were spread across 3 of our 4 buildings. You can see the science team obviously mostly came out of the science building at the top of the view here. We developed 2 of the instruments, so EMUs and EXI, as well as providing critical mission support out of the mission support facility from the main building. And then me and the most of my program management team were actually in the ARL building, along with the majority of spacecraft development, and also the assembly integration of that spacecraft, and ultimately the integration of the instruments and the testing of that overall system. If we zoom out one, you see a view of the country here. And this is, you start seeing coming into play here a number of the subcontractors that I was referring to before. And there's this green line, which I'm going to talk to in a couple of view graphs here. So now we've zoomed out to the world level. This is the overall view of the world, and you can see some of the international players that are shown here. For example, MBRC subcontract to MHI in Japan to secure launch services coming out of that country to provide the launch for EMM. But again, there's this green line. This green line depicts this collaboration, this partnership, specifically between MBRC and LASP. And that is really where I'd like to talk in the next couple of minutes here. So there's lots of different kinds of collaboration. There is the kind of collaboration where organization A makes widget 1, and organization B makes widget 2, and those widgets get combined, maybe with third organization, maybe with one of the other two. This is a very successful and common collaboration model, and one that I've certainly been part of, and most of you have been as well if you're employees at LASP. This is not that green line. Another collaboration model is more hierarchical, where you have a top-level organization and a different lead organization, and then maybe some subcontractors. And I just described EMM, part of EMM organized actually just like this. But again, that's not that green line I was showing, how the collaboration was implemented between LASP and MBRC. Instead, it was something more like this. Each organization has within itself people, a person represented by each dot here, organized in much the same way. There is a lead, let's say it's a program manager. They work directly with group leads. They work in turn with a series of people in maybe a product development team. And so, you know, rather similar organizations from that perspective, but that green line shows this. It was a merging, a homogenization of our two organizations at every level and within every system, where each person was paired up with a collaborator on the other side. And so in this way, you know, from my perspective, this is a first. I don't know any other program that has been implemented in this way. And if you think this is hard, you're right. This was hard. It was definitely the difficult way of implementing the program. And it was the way that the UAE chose specifically to get that tacit knowledge, that knowledge transfer, that experience at all levels of a program. That was essential to meet those goals that I spoke of earlier. This took trust, organizational trust, personal trust. If something good happened, it was immediately known. If something bad happened, that was immediately known. I mean, it was one team acting together. And you know, again, at an organizational level, at a personal level, this works only if there's a good deal of trust. It involves selflessness. You know, this homogenization came inherent with the need for individuals to recognize that they're necessarily teamed up, and that an individual accomplishments were not as important as the group accomplishment. So a little bit of a shedding of egos, perhaps, and a more embracing of an overall team. An embracing of the concept that helping others excel is really how this program is going to thrive. And openness to new ideas, new approaches, certainly an acceptance of impact to personal lives. I mean, this program operated in the early mornings, in the evenings, over weekends, as you just heard. Right, Mohsen is this is 6 o'clock in the morning for him. You know, this became commonplace for us over the last 6 years. So personal lives were impacted constantly on this program. And for those all to work, there had to be understanding of all these points. Any team benefits from these points. The EMM team, it was critical that each of these ideas was embraced. So the collaboration and partnership was uniquely implemented both at an organizational level, again, the hierarchical and personal. It was a very different type of collaboration. I don't want to get too much into this, but for those of you who are aware, the U.S. as other countries do, control the flow of technical data flowing out of the country, and there are federal laws in place to restrict and control the flow of technical data. So that appears to fly right in the face of the overarching programmatic goal of knowledge transfer to the UAE. So this really was the first CU program to have an established authority to export technical data to a foreign country on a broad range of space technology topics. Now, the entire EMM team operates under a license that enables all of this. I could spend an hour talking about this one aspect. Obviously, I can't, but the process to obtain that license required for support on many different levels. It actually specifically got support from NASA, which was key. And ultimately, the license and the process we took to obtain it was embraced by the Department of Defense and the Department of Commerce as the way that this type of program should be implemented and licenses obtained. This was a big shining star for CU, LASP, and our ability to gain this license. And again, is another mark on that unique aspect. I'm not going to spend very much time on this. This is our overall mission timeline. I'm not saying this is unique. This is compressed. It was challenging for sure, but this in of itself is not particularly unique. What's unique is that there's nothing to the left of it. There was no proposal phase in this program. We went from blank page to fully scoped in 100 days. I could talk again for a long time about the pros and cons of that approach, but it certainly galvanized the team. And I would argue we did an exceptional job sticking to that overall construct at the end of those 100 days for the remaining six years. It's quite remarkable the product that came out of that. Again, unique to my experience, and I think unique for the overall program. I don't really have time to go over these slides in the depth I wish I could, but just to know that also driven by the need to have our all our partners and the Emiratis in particular involved in testing that really precluded the use of our usual go-to places such as Ball Aerospace and Lockmart. So we actually developed the capability to do this kind of testing in-house in the ARL clean room. And so here you see a setup for acoustic testing in which we bombarded the spacecraft with sound pressure equivalent to a jet engine at 100 feet, very impressive test. We then repurposed the clean room again to act as an electromagnetic compatibility interference testing chamber. For those of you who know what that is, it's impressive that we're able to get there and we have that capability now. Doing separation testing and shock testing is not particularly new, but we did bring into this picture state-of-the-art equipment in order to do that, which now is part of LASP capability, as is the measurement of large masses and CGs to a high degree of precision. So important aspects there from a testing perspective. Also, as a product of the EMM program, we have this very nice clean room, high bay with dimensions that you can see here. And as an integral part of that is this thermal vacuum chamber, which is, if anybody's familiar with thermal vacuum chambers, again, the numbers are here and these are very impressive numbers. So this is a really nice facility that absolutely enabled EMM and will move forward as a very important capability for LASP in the future. So I'm going to round this out now. I want to say that one of the aspects of this program that we gained a significant benefit is having just an excellent review team. Some of the membership of that review team, the names will be familiar to you if you're employees of LASP: Mark Langton, Jim Westfall, and Randy Davis. Now, Randy Davis has been a reviewer for us for several years now, and he was kind enough to remind me that back in November of 1971, the Mariner 9 spacecraft entered orbit about Mars. Now, that was the first time a spacecraft had ever entered orbit around Mars. In fact, orbit around any planet, for that matter. It was a special time for LASP because on board was LASP's ultraviolet spectrometer. In fact, if you regularly walk into the lobby of LASP, you'll see the engineering model of Mariner 9's predecessors sitting at the west end of the lobby there. But it is fascinating to note that 50 years later, LASP finds itself in this unique partnership with the UAE. And in that collaboration, we have successfully developed a deep space spacecraft. We've navigated it into Mars orbit. We've developed 2 of the 3 instruments, which are now ready to perform this compelling science observations, and provided mission operations support, all inside of this unique collaboration and partnership. It is a remarkable achievement, and it's a testimony to how impressive the team is, and it's a great achievement for LASP overall. So what makes EMM unique? I hope I've answered that at least to some extent. And with that, I'm going to pass the rest of the description of the journey onto Mohammed. Thank you.
Okay, Pete, did you want Mohsen to go next? I thought the plan was for me to go second and for Mohsen to wrap everything up.
Go right ahead, Mike. I think I have the order one.
Okay, all right, cool. I'm happy either way. I totally agree with you, Pete, that this is a remarkable mission in a bunch of ways. And one of those ways is that the team is a real strength. So I'm Mike Chaffin. I'm a member of the science team. I was on the science definition team for the mission. And I feel really lucky to be part of an international team, which includes first-rate scientists from around the United States and around the world, and also includes Emirati science apprentices who are transitioning from earlier careers in engineering and on their way to being first-rate scientists themselves. And as the data starts to come back from EMM and as we start to write scientific papers, I think you're going to be really impressed with the observatory that's been put together. Pete described a lot of the capabilities, the engineering capabilities and the engineering development that had to go into making the science possible. And I'm going to tell you a little bit about what the vision for EMM is and what science we hope to do right now. So today, if you go to Mars, say you were standing on the surface next to the Perseverance rover and you poured out a cup of water, that water would try to boil and freeze at the same time. That's because the atmosphere of Mars is really thin. It's thin enough that the boiling point of water is that liquid water can't exist at the surface because there's not enough atmospheric pressure to hold it in. And it's cold enough near the surface that liquid water can't exist because it tries to freeze. But we know from abundant evidence from those surface rovers and from multiple orbiters over the last 50 years that Mars once had a thick atmosphere. We know this because there are deltaic features on the surface, riverbeds and ancient lakes that could only have formed in the presence of liquid water. And there are also chemical changes that the surface has undergone. So here's an image of a drill hole from the Curiosity rover, where drilling just a little bit into the surface, you immediately see that the whole surface of the planet has rusted, it's oxidized. And this indicates that a great chemical change has taken place over the last 4 billion years on Mars. We know now, thanks to MAVEN and other missions, that the ancient thick atmosphere of Mars was lost to space, leaving only the thin atmosphere that's currently present. And even though that atmosphere is about 200 times thinner than the Earth's atmosphere, comparable to densities that you would get in the Earth's stratosphere, it's very interesting. Mars has dramatic weather patterns, in some ways more dramatic than any weather patterns that we see on Earth. So this is a pair of images from the Hubble Space Telescope showing you a global dust storm that occurred in 2001, where the atmosphere over the course of just a few months went from being perfectly clear to being almost completely obscured by dust. These global dust events are weather patterns that start out small, but that snowball and eventually cover the entire planet in a single weather pattern. And thinking about this phenomenon on Mars, it's really pretty unique. Nothing like this happens on the Earth. I mean, can you imagine if the entire planet were subject to the same weather front or storm? And these kinds of events are one reason why studying the atmosphere of Mars is so exciting, even though it's so much thinner than the Earth's atmosphere. Another reason is that the atmosphere of Mars is really closely interconnected from bottom to top. I told you about these dust storms, which are very interesting in themselves, just from the point of view of understanding the dynamics and the structure of the lower atmosphere. But over the last few years, multiple Mars missions have told us that the atmosphere of Mars is really deeply interconnected, that what's going on in the upper atmosphere over billions of years can affect the composition and structure of the atmosphere, but also what's going on in the lower atmosphere today can affect escape to space and evolution over time. So on the left-hand side of the slide here, I'm showing you an orbital image of a small localized dust storm. And what's been shown by MAVEN and other precursor missions to EMM is that the atmosphere of Mars responds really strongly at all altitudes to dust events like the one that's being shown in this picture. And water near the surface can be lifted up in these convective dust events. There's a lot of churning in the atmosphere that is lofting this dust up. And in addition, the dust, because it's suspended in the atmosphere, can absorb sunlight and heat the atmosphere locally. So the reason why a global dust storm can occur is because you get a feedback loop where there's more dust in the atmosphere, and so the atmosphere gets hotter, it starts to get more turbulent, you get more dust in the atmosphere, and if the conditions are just right, that snowballs into a global storm. But in all dust storms, we see a local heating of the atmosphere, which can carry water up from the lower atmospheric layers to very high altitudes, altitudes of 60 or 70 kilometers, higher than was previously thought possible. This is really important because on the Earth and on Mars under normal conditions, water is trapped really close to the surface. Every puffy cloud you see is water trying to make its way back to the surface here on the Earth. And it does that because the atmosphere gets colder as you go up in altitude. But on Mars, when these dust storms occur, there is no cold trap. The water doesn't condense into clouds, and it can instead make it into the upper atmosphere, where it can be broken apart by intense ultraviolet sunlight. And once the water is broken apart into hydrogen and oxygen, it can escape away into space. The hydrogen more so than the oxygen because it's so much lighter. And what we know now on Mars, thanks to 50 years worth of previous missions, is that the atmosphere is dynamic, it's variable, and it has structure at all locations, at all scales, and at all altitudes. And we really need to make dedicated measurements of the atmosphere at all altitudes in order to understand it. And that's where EMM comes in. The Emirates Mars Mission has a really comprehensive observatory which measures the atmosphere from bottom to top. And this will enable new science. So there's 3 instruments on EMM: the Emirates Mars Infrared Spectrometer, or EMIRS, which was built in a partnership between ASU and NBRSC. And this instrument measures in the infrared heat radiation that comes from the surface or from dust in the atmosphere. And this instrument is sensitive to the lowest layers of the atmosphere. It can measure atmospheric temperatures in the bottom 10 kilometers or so. It can measure dust and dust storms and characterize very precisely how much dust there is in the atmosphere and how much water there is in the atmosphere as well. Going a little bit higher in the atmosphere, the Emirates Exploration Imager, or EXI, which was built in a partnership between LASP and NBRSC, is a camera. And it's a really good camera. It doesn't only contain the ordinary red, green, and blue filters that a space-going camera usually contains, but it also includes some near ultraviolet filters that look a little bit shortward of the light that our eyes can see. And this instrument is designed to take great pictures of the surface of Mars, of course, but it's also very sensitive to clouds, both water clouds and CO2 clouds. Most of the atmosphere of Mars is CO2, and sometimes it gets cold enough for that CO2 to condense and make clouds. It can also measure ozone, which is created in the atmosphere when CO2 is split apart by ultraviolet light. Going even higher in the atmosphere, the Emirates Mars Ultraviolet Spectrometer, or EMUS, which was built in a partnership between LASP and NBRSC, measures ultraviolet wavelengths. So even shorter than the near ultraviolet filters in the camera, we have a dedicated instrument that is sensitive to the highest altitudes in the Mars atmosphere and can measure reflected sunlight from oxygen and hydrogen and carbon monoxide in the upper atmosphere, all of which are breakdown products of the CO2 atmosphere and of water as the atmosphere and the water escape into space. And importantly, EMM will get all of these measurements more or less simultaneously from the bottom to the top of the atmosphere, enabling us to probe how the atmosphere is vertically interconnected, but also enabling us to do a broader scale investigation of atmospheric phenomena than has been possible on previous missions. Pete talked about the uniqueness of the EMM program. The orbit of EMM is also unique. It's a very large orbit compared to other spacecraft. You can see an illustration of how far out we get compared to previous NASA and European Space Agency missions. And the reason why we're in this orbit is because it allows us to observe almost all of the surface at almost all times of day. The orbit is about 55 hours in length. And so that means by the time we go around one orbit, we're not observing the same real estate underneath the spacecraft. And we can put together a comprehensive picture of how the atmosphere and the weather and the climate evolve at all latitudes, longitudes, and local times. And we're planning to do this for a full year on Mars, which is almost 2 Earth years, enabling us to make measurements of the seasonal changes and contribute a great deal to the understanding of the Martian climate. EMM is really important in this regard because the previous missions have not only been confined to these low orbits, but they've also typically been synchronized at one local time. So the Mars Global Surveyor spacecraft, for example, only measured the atmosphere at 2 p.m. and at 2 a.m. And that skews your statistics so that you can really only understand the weather and the climate of the system at those times of day. But with EMM, we'll have a transformative collection of data that will enable us to make significant progress on understanding the climate of Mars and how the Mars atmosphere is evolving today. I want to show you the first image. This is the only image that's so far been released from EMM, and it's gorgeous. I think that this image was placed where it was because of engineering considerations, but it's hard to imagine a better first image. Like if you're going to observe anything on the planet, this collection of volcanoes and the Valles Marineris is just a treat. And I want to show some snapshots and deeper looks at this image that was put together by Andrew Jones, who works on the camera, EXI. And if you zoom in on different regions in this image, you can really get a sense of the power of this instrument to observe clouds near the polar hood. The delicate structure of these clouds as the polar hood and the polar vortex rotate. To look at the volcanoes and clouds inside the calderas of these really tall volcanoes. To look at Noctis Labyrinthus and Valles Marineris, the largest canyon in the solar system. And to see these high clouds above the terminator that are reminiscent of noctilucent clouds that we see here on the Earth, clouds that as they rotate into night remain illuminated well beyond the sunset. And just for extra fun, we have a bit of a photobomb in this image. We didn't intend it, but Phobos, the Mars moon, is visible as a single bright pixel just off the night limb of the planet. So this gives you a taste of what we're going to get with EMM. Going forward, we'll get dozens of images like this in every orbit that will enable us to do cloud tracking and really paint a picture of the Mars atmosphere in a way that we haven't had before. I unfortunately can't show you first images from either of the other two instruments. That's not because we don't have them, but it's because we're planning a coordinated release next week. For the last 3 days, I've been involved with my scientific colleagues on the mission in our first science team meeting since we got to Mars, and the results are really spectacular. We're getting temperature maps. We're able to do our retrievals of dust and water in the lower atmosphere. We're getting measurements of the upper atmospheric oxygen, hydrogen, and carbon monoxide. And we're seeing wavelengths at Mars that we've never seen before. So look forward to images that look a lot like these from, this one's from the Mars Global Surveyor, this one's from MAVEN. But EMM will make images like this multiple times per orbit. Importantly, we'll do it over the course of a full Mars year, whereas these observations from the Mars Global Surveyor and from MAVEN were limited to the insertion orbit only. Whereas now we finally have a chance to make measurements like this across an entire Mars year. So stay tuned for that. I can't wait to see what we find at Mars, the scientific insights that we'll be able to generate to the community and propagate out to the general public. And I hope you'll stay buckled in as we go on this scientific journey. So I'm going to stop there and let Mohsen take over and talk about the Emirati perspective on this really unique mission.
Can I confirm that you're able to see the screen and hear me?
Sounds good and looks good.
Okay. Thanks, Mike. So yeah, my name is Mohsen Al-Awadi from the Mohammed bin Rashid Space Center in Dubai. And I think what I'll try to do here, talk about the way I was seeing the mission. So Pete talked about the big overview of the mission, how we made this mission possible, and how such a complex mission was able to be achieved within a really limited time compared to other missions. We only had approximately 5 years to be able to have a product of a mission that I'm sharing here with you. And I think I use whatever chance I have now to share this picture, and I have it saved on my wallpaper, my iPhone background. So to be able to sit down and look at this and say, this is something we have worked on is just unbelievable. And Mike also mentioned about the science impact when it comes, to the science community worldwide, understanding what this mission will be providing. So what I'll be trying to do here throughout my slides, I'm basically sharing some personal photos as the way I was seeing this mission from day one. So taking it back to 1976, which I think most of the team was not even born back then. This is almost 5 years into having a country called United Arab Emirates. The middle, Sheikh Zayed, the founder of the UAE, even back then, he knew that he wants this country to achieve the impossible. looking at the region, looking at where we are from, no one has done such a thing to go even consider space as a field for the country. But the country was only 5 years old back then, and he was meeting personnel from NASA where they were talking about the shuttle program. I think this was 4 years before the shuttle program started. He was into it. He was beyond looking at the skies. He wanted to go beyond that. And I think we did achieve that, not with only EMM, but throughout the different missions that we have, the Earth observation satellites that the Space Center has, and then the astronaut program that we sent a couple of years ago. But the impact of this mission and being able to achieve deep space mission, I think it was not just for the country, it was for the region. And that's why the name HOPE really stands out. It's not only for us, it's not only for the UAE, but it's for the region, for the Arabs. And I'll try to talk about the importance of this mission again, as I said, from my point of view, and go through it in a timeline. So whatever I was able to find some pictures that I can talk about. So this is back in 2015, when the team first came together, or not first, but at least this is one of the major events. This was during the first milestone, the system definition review and system requirements review. From back then, as Pete was talking about how the team came together, we did not work separately. Each person here had a counterpart from LASP. Each engineer, each science member had a person that was basically guiding them, helping them, and trying to make them understand what it takes and what is needed from them to be doing on this project. And this is when, again, this is, maybe I'll take it a little bit personal. This is when I moved to the US, when I was given the opportunity to move out to the US, spend full time working with my counterpart, and specific Nick Farrington, who was basically teaching me and then giving me ownership of different things that I need to do for the mission. Going a little bit forward, I'll skip a couple of years, but this is a picture that really, I need to frame this. This is when we had this is again, not the whole team. This is maybe less than 10% of the whole of the team. This is some of the spacecraft team. And back, and the guy in the middle in the green sweater, basically, that was the chairman of the UAE Space Agency back in 2018. His Excellency was also the Minister of Higher Education. Next to him is Sarah Lamiri. Her Excellency is now the chairman of the UAE Space Agency. So this visit was from the stakeholders coming to Boulder, CU, LASP specifically, to come and see the progress of the mission. And at that point, this is almost 3 years into the mission. Each single person here in the photo learned so much in that 3 years, and they were able to stand and explain what they were working on and their responsibilities and what they have achieved and what is to come. This is, as I mentioned, 2018. We were not anywhere near being done with the project or being done with the development of the mission. But I remember really clearly, I was managing the team back then at that time. And the words that I was hearing from their stakeholders, that if there was any doubts that this team might not be capable, the UAE's team, that doubt is not there anymore. That was a really personal thing for me to hear. And it had a really amazing impact on the team and myself as well. And we would not be able to do that without having the right partners. CU Boulder, specifically LASP, they made this generation, I call them Generation Hope. They helped shape this set of engineers and scientists to come in the future. As I said, I mean, it's really, whenever I remember that day, it's amazing to see how we were able to, in a short time, in 3 years, to be able to prove that this mission is working, prove that the concept of the mission is working, and that the green and the blues that Pete was showing that actually is working. It wasn't easy. It was hard. We had a team like myself, who had to leave family and friends and be in the US for 5 years. Then we had a team that had to travel between the UAE and the US at least 6 months out of the year, different time of the year. And then we had another team that was basically based in Dubai, but they would come to the US every now and then, but they were doing most of their tasks from Dubai. So it wasn't easy for anyone. And the time difference, 10 hours goes up to 11 hours. Being able to, try to maintain a healthy life, personal life, and then also on the mission was not easy, but it was easy to be achieved because every single person, not only from the MBRSC's team, but also from LASP, they really believed in this mission. And I think we have some engineers that are they have experience worth of our age they were just so impressed and so excited to work on this mission. And that was really impressive. And this, I tried to block it, so I'm not doing any export issues, but I think that would be fine. And I'm not good in Photoshop. So this is, again, the team talking to the stakeholder on what they know and what they've learned and what's to come. Left a really beautiful impression. And the trust, for sure, the trust back then went 100%, if not more. And again, this is mainly because we were able, and LASP was able to deliver and be able to get that objective of knowledge transfer successfully. Understanding from day one that going to Mars does not mean you have a successful mission, but having a team that is able to understand the design and work on the spacecraft and work on their subsystems, that was the ultimate goal. Having a team from the UAE that knows not a lot, if nothing, about any deep space mission, and have them ready at that point. And of course, we're still learning even till today. But the jump that we have made was one of the main objectives of the mission, is that we are learning this. We're not just buying the product and then be able to operate it. No, we were told from day one, you're going to design it, you're going to help build it, and then test it, and then operate it. And also while there, a bunch of us got an opportunity to get our master's degree. This is, again, me talking personally, that thinking that I'll be able to work with that university was not even in my dream, with CU Boulder and LASP. But given the opportunity to also continue my education and get my master's degree in aerospace engineering, and working at the same time, being trained on the mission, was absolutely amazing. And it just leaves really beautiful memories for me and for the team that did this with me. It wasn't easy, again. It was a hard couple of years that we had to go through. But again, looking at it now, I'm really glad that we took that opportunity. And it was, again, just whatever we were doing on the spacecraft, whatever we were learning, I was doing that again in class on a different project, just making sure that I understand what I'm doing. And having these opportunities to work with such a university was totally amazing. And I was also seeing that even the university in the school, they're doing the same thing. Whenever we had a school project or a class project, it was the same way. The method that CU Boulder was following made me understand why you really get great students out of this university, because many of the team from EMM as well, the younger ones, were just graduates from CU Boulder. And it was easy to understand why CU Boulder is doing a really good job and having really amazing staff. And I think this is in 2020, a couple of months after the graduation. What I'm trying to show here, this is the day we shipped the spacecraft from Denver to Dubai. And I was given the role of being the director of the move of the spacecraft. That meant that the team trusted me enough for me to handle this operation. And it just shows that how much they trusted in us and how much ownership they gave us whenever we had any tasks. And this is one of those tasks that I was like, I never said no to it, but I was really stressed about it. It's a big operation, but the team believed in me, and the team in LASP and CU were able to get me to the point that they're actually trusting me with the spacecraft. This is one of the biggest challenges and a really high risk operation that we're doing here. And it was just one small example on how we were taught and how we were trained to be able to stand today and be able to operate the spacecraft, troubleshoot it if needed, and basically understand what it takes to get a mission to deep space and to Mars in a specific. So I'm trying to show some picture, I think, of the impact that I was talking about. So we saw the impact on the team. We saw how much they improved. We saw how much they learned throughout the 5 years, 6 years with the mission. But the day of MOI, this is specifically with MOI, and these are just some small pictures or a small set of pictures that showing how the whole country turned red in celebration for that big achievement. Even though we did not make it yet, we were not still an MOI. We were just a couple of hours or maybe some days before MOI. But everyone was just so excited. People who didn't know a lot about science or didn't know a lot about space, they all tuned in. They all really felt like this is an achievement that they want to be part of by watching, by being around. And I don't want to compare it exactly to the Apollo days in the US, but the impact that it has, and I was not there back in the Apollo, but my father tells me that he was listening on the radio. I think they didn't have TVs back then in here. And he was just tuning in and hearing, about the mission and what's happening. It reminded him exactly of that. And it just was hard for him to believe that in his timeline, he was able to see that. He was able to see a country like the USA doing such a big thing and sending human to the moon. And then the UAE is on a mission to Mars, and watching the TV, and I think he was stressed more than myself on that day. And it was, I think the impact is just really hard to capture by photos. And this is, I think, this does not do justice to the photo. This is once we did the successful MOI, and then we had the leaders of the country coming to us and congratulating us. I mean, of course, they were there on the day off. They just showed up. They talked to us, and we were confused. But this was set a couple of weeks after that, after the MOI, where they came to us and they talked to us and showing us how much this mission means to them. So what I'm trying to say, I think here, the impact that this mission had, it's still ongoing. Kids, young students, college students, they all now understand that there are opportunities and areas that we never thought that we can have a chance in being part of. Transferring that knowledge from the US, from CU Boulder and LASP to the UAE is another achievement that this mission was, the mission wouldn't have been successful if that was not achieved. But being able to sit down today and saying that, yes, we have achieved that, and then the leaders of the country are accepting and saying, yes, that has been done, and they can see it. We've been proving it. It is just amazing. I can keep going. I have more photos to share, but I think these were just some that I feel like it shows, at least on a little scale, how much impact that this mission has left. And also to note, this is in the UAE, but worldwide, I think I was surprised by how many countries were congratulating the UAE on the mission. I think that is something we were not expecting. We felt like if we get a positive feedback from the region, that is mission success when it comes to, giving the hope message to the region. But I think it went beyond that. And I think what this mission has done, the collaboration part, I hope that all the mission will look like this from now on. This is, I think, one of the best ways to do it. For myself to be able to sit here and be able to now talk to Pete and discuss ideas is something I would have been able to do 5-6 years ago. So with that, I thank you for the opportunity and pass it over to Heather at this point.
Mohsen, thank you so much. It's been a pleasure working with you. Here, let me get my video going. I can make my presentation as short or as long as we need to, but I'm going for short because we've heard a lot from everyone about what we were trying to accomplish, and also, I hope everyone can hear me. And also, we would like to get to some questions and answers. So someone's going to text me if they can't see my screen. So this is a map that represents where we were needing to cross oceans to visit each other. And in some cases, we brought our families. And in other cases, we stayed short times or long times. But regardless,
Hey,
to get
Heather,
there, yes.
we cannot see if you're sharing a presentation. We can only see you.
Oh, well, there we go. Excellent. Here we go. Sharing a screen. The first one was really boring anyway. Here we go. It's just a map. Okay. Sorry. I am Zoom professional, but that wasn't obvious. Yeah, so just a reminder of crossing oceans and bringing our teams together by doing so. I also have pictures that I'm sure will advance for me. Okay, good. Let's go through questions and answers, and we'll just have some pictures come up in the background if my computer decides to listen to me. So Mike Chafin, can you talk about a couple of questions? I think you already answered in the question answer bucket, but I don't think anybody else got to see or hear what those were.
Sure, yeah, I was typing answers to questions as they came in. So there was a question, is there a close opportunity, or is there an opportunity for a close flyby of Deimos? So some of you noticed in the diagram of the orbit that I shared that our periapsis, when we get closest to the planet, is very close to the orbital distance of Deimos. And so there is a possibility for close flybys. In fact, we'll have to do collision avoidance just to make extra sure that we're nowhere near the moon. And that's kind of a natural part of the planning process. We can also tweak our planning process so that we do get a close flyby. And we hope that we'll be able to do that. But the baseline science plan for the mission involves making atmospheric observations. So our initial goal is to make sure that all of that is going really smoothly, that we're getting all of the observations that we need and fulfilling our science objectives. And then we will hopefully have some time over the next couple of years to do the planning that's required to make those flybys happen and then get some science results. And there would be a lot of cool science that we could do.
Thank you, Mike. Here, let me just try to do this one last time because I was successful for a second there.
Sure.
Okay. So some of my questions look very similar, or sorry, pictures look very similar to, I don't know, look very similar to what Mohsen was showing, and that's because we got together a lot. So the beginning of the mission, the question is, what do you do to bridge two cultures? And what you do is get to know each other. And so we had a lot of really large meetings between 80 and 100 people to understand each other's viewpoints, to share ideas about what was going to happen next, because just to say you're going to go to Mars is not the same as to say that you know how you're going to get there, what hardware you're going to build, what platform you might ride on, things like that. And so those were the types of things we were talking about early in the mission. Sorry. But the other thing you do is you share food, because this is one way that you can really find out more about each other's habits, families, interests, world travels. And so we did that quite a bit. We also needed to work side by side. So in the lab, in the clean rooms, in the Mission Operations Center, we are sharing time, sharing ideas, and sharing tasks. And that's really how we came together. So that's different than maybe some other international collaborations where you might work on it in your own country and then bring the finished product to an integration and say, here's my thing, let me bolt it on. And that's not what we did. Everyone was together for all things. And so institutions had different responsibilities, but everyone was sharing in the work for much of it. We also had fun on both sides of the globe, hiking in Colorado, out on the sand dunes in Dubai. And then we celebrated. So you saw the picture that Mohsen had of the graduates. This is our cake. We serve cake for a lot of things. our cake picture for the graduates of who came through their aerospace graduate program. And then on the left, we're all signing essentially a banner that was like a goodbye card to send the spacecraft from Boulder off to where it was going to go next, which was at that time Dubai. So this is the spacecraft, if anyone hasn't seen pictures before. And it has this really big high gain antenna on it. That's how we communicate back to Earth all the way from Mars. And those solar panels are there to give us the sun and keep recharging our battery. Everything is going really well. Like Mohsen said, we took Vogel de Dnieper was what we needed to get our shipping container into an airplane for transport. And that was for our first big event, our first critical event, which was launch. That was a successful launch in July of 2020. And the next thing you need to do is get to Mars orbit. And we successfully completed Mars orbit insertion on February 9th. So there were many things that could have gone wrong and some things that did go wrong. And none of them stopped the team, our ingenuity, our interests, and our common goals from making it to Mars. So we're pretty proud today and we're pretty excited. And we really appreciate that you've joined us for this discussion. So let's finish the Q&A. Mike, do you want to speak to one more question you may have answered online?
Sure, I'm happy to. So we got a question about the difference between CO2 clouds and water ice clouds. When you look at the camera observations of the surface, like in the image that I showed, there weren't a lot of clouds in that image. There were some at the north and the south. But we generally, when you see a cloud, it's just a bright white thing in the image, and you don't know whether it's a CO2 cloud or a water ice cloud. There are ways to tell them apart. So that the question asked whether they occurred at different altitudes or at different seasons. And the CO2 clouds do tend to occur higher up because they need colder conditions to form. But on EMM, we're going to have to rely on our judgment, because in the images of the planet, we're not able to see what altitude the clouds are at very easily. So we'll have to rely on models, climate models of the planet, or on our judgment to be able to tell which is which. The CO2 clouds are much, much rarer than the water ice clouds. So if you see a cloud on Mars, it's probably a water ice cloud and not a CO2 ice cloud.
Thank you, Mike. So we have another question. Will any of the studies give further insight or focus on giving more insight into the seasons on Mars?
Yeah, that's a great question. I was just typing an answer to that. And so Mars has more intense seasons than the Earth in some ways. Southern summer on Mars has really intense winds and dust storms, whereas northern summer is much calmer and has very few dust storms. And we don't really have a good idea on Mars for how these dust storms get started and how some of them eventually become global storms. That's still a mystery. We don't know why they only occur in every 2 or 3 Mars years. We don't know exactly what the conditions are that turn a local storm into a global storm or cause it to die out. And EMM's observations will make observations of dust at all local times. So we'll be able to track the evolution of these storms as they move from dawn to noon to midnight. And that should give us a lot more insight into how these storms form and how these seasonal dust influences affect the planet over time. So we'll be overflowing with data on the seasons and on the climate, and that'll enable us to make much better models. It's a little bit like weather modeling on the Earth, right? Your weather model and your weather forecast is only as good as the temperature data and the wind data that you feed into the model that produces the forecast. And on Mars, we've never had the kind of data that EMM is going to produce before. So we'll really get a much better sense of what's going on.
Thank you, Mike. Pete, can you answer, can we hear more about the international data export control?
Absolutely. So we got a couple of good questions about export control. I'll say I really resonate with this question as large, maybe not even just large, just space endeavors in general. become more international, the U.S. export control regulations become more and more important. I'll say a couple of quick things, and I'll preface by saying neither of these comments are going to be particularly helpful, but I'll start. Export control, first of all, it enables the being compliant with the U.S. regulations. So I wanted to make that clear from how the question was written. It is an expensive process. It's a timely process. The expertise when we started this program did not exist at LASP. It did not exist at CU. We actually reached out to a legal firm in Boston because they had specific international export law expertise. And they also had the right tendrils into the US government to grease the skids before our license application hit the Department of Defense. So that's, I'll say, hard to find. It's expensive. Even once you get the license, it puts regulations and processes on your program that in themselves add inefficiencies and costs. So that is also an unfortunate inherent aspect of being compliant with the US laws. So two aspects to keep in mind there. Your question correctly differentiated between ITAR and EAR, and I would emphasize that if you're actually looking into getting a license, understand the difference, because there's a big difference between the two. The Department of Defense really regulates ITAR. If at all possible, you want to stay away from that, because that usually involves technology of national security importance, and that will put a lot of regulations on your team and organization. If you can at all obtain export licensing under EAR, which is administered out of the Department of Commerce, that's going to make your life much easier. So there's a lot more complexity, but I'll leave it at that for now.
Thank you, Pete. There's a question about the number of women on the UA team, and perhaps that should be a goal, especially in US teams, and certainly it should be. Just for everyone to know, I believe the number is just above 30% of the team from the UAE were women, and they had all positions of responsibility. And that was awesome to both work with and to see, as they were all young engineers. Everyone on this team started as engineers in the UAE. And so we really did have a wonderful time, and they set a great example. I think the last one that's open here is a question about whether or not EMM is carrying Electra to relay the data from the NASA rovers. Pete, do you want to take that?
Sure, I can take that. It's actually a simple answer. The answer is no. It was part of our trade study early on. It was an option to have it. But just as a quick answer, I'll say that having Electra on the spacecraft is resource intensive and would have driven costs in an area that we could not have supported on the EMM program. So ultimately, unfortunately, we had to say no to the Electra.
Thank you. So I want to thank everyone for listening about EMM today. And what we would chant while we were hoping that we would get to Mars was hope at Mars. And so we are there. It's very exciting. And I want to turn it back to Amy for upcoming events.